So, hi. I got this active balancer and I would like to explain how this thing works more or less. It will be more understood. So in my example I have 4 battery cells. They are all connected in serial, which means this is the main negative and this is the main positive. Of course, in order to get more voltage, I need to connect the plus of the first battery to the minus of the second, the plus of the second to the minus of the third, and so on. What active balancer is doing, instead of discharging the highest cell, it's doing a comparison which the cell has the highest voltage. So it's comparing the voltage of these cells compared to these cells, the voltage of this compared to this, and it will find the highest voltage. Let's say this battery has, for example, 4 volts, this one have a 4.1 volt, and this one have 3.6, and this 3.8. So what the active balancer will do, it will take the highest voltage. In this case, this is the first and this is the second, and it will transfer current from these cells to the other cells. Now, how this can work? Basically, we have a DC to DC MOSFET with a coil. So we can activate this circuit and create voltage in order to add power to this battery. Or in this case, we need to add power to this battery. We need to charge this one, and we take voltage or current from this one and move it to both cells. Now, how can this be? We have, for each MOSFET, we have a control that oscillates this circuit and monitor the voltage and the current every few milliseconds. By this, we can transfer. Now, the question is how to take, if this is the power, we need to take this power to our circuit and not use other power. This is basically pretty simple. We have here MOSFET switch, and if we would like to take power from this cell, so we will close just this two MOSFET switch, and we will take this power to our controller and the circuit, and we will take in this example this power to the second controller in order to charge this one. And every second we are monitoring, and when all the cells are balanced, so we are stopping the process and it is completed. Okay, so I have this circuit. It's pretty hard to see what is inside, but you can see that there are only 3 coils. Okay, for 4 cells we can use this circuit with 3 coils, no need for 4. And the question is, where is the controller and all the comparator and everything that I said? So it is here. We have tiny chips, and this chips is the controller for each branch, and this is how this is working. In order to show in real life, so I took 4 cells like in the picture, and I connected all in serial. So let's first use a DVM to see the voltage of each cell, and we will then check if this active balancer is really working. So this is the main minus on this side. So here we have 3.65, the second 3.5, the third 3.52, and the last 3.63. So we have difference Let's see if we connect now this balancer. I've already done all the wiring. What will happen? So you can see that one LED is turning on, which means it is taking charge from one cell to another. When the action will be completed, so all the cells will be balanced. I will leave it to work, and then by the way, the current of this one is 1.2. It is limited. This is very important because you don't want to transfer current or electrons too fast, because this can harm the cells. It is like shorting between them, and shorting between them is not a good way to charge, because you shorten the lifetime of the cell. So I leave it here to work, and we'll check later to see if all the cells are balanced and what is the difference between them. So we can see that it is working. By the way, if the last cell was higher voltage, so you would see, you can see 2 LEDs or even 3 LEDs that are transferring current from one to other, but in this case it decided now to do just one transferring, and during the cycle, maybe if the voltage will be too low, it will continue using other LEDs and continue transferring between the battery. So that's all. I leave it to work, and we'll check later to see. Okay, we can see now 2 LEDs are lighting, which means there are 2 transfer, not just from one cell, but from 2 cells to 2 other cells, because the voltage decrease, and now it's need to do continue with the balancing. Okay, let's wait a little more. Okay, so the balancer stop blinking. Eventually I've waited all night. Let's see the voltage. Cell number 1, 3.6. Cell number 2, 3.58. Cell number 3, 3.57. And last cell 3.62. 50 millivolt. As a matter of fact, I expected to get something a little more accurate, but 50 millivolt is less than 100 millivolt. I think this is okay. I think this is okay. I would expect maybe something a little more accurate, but I think this is okay. You can say that this is plus minus 25 millivolt from the upper to the lower cells, so this is okay. So bye.